Hi, this is Bradley Bush. Today we're going to talk about function compositions. So adding, subtracting, multiplying, and dividing functions. This is pretty straightforward, pretty common in algebra. You are given two functions and you want to add them, you want to subtract them, you want to multiply them, or you want to divide them. It's a pretty big chunk of algebra. So let's talk about it. I think you'll find as we go that it really isn't new. There's just some new notation. And once we get that new notation under your belt, then I think you should be really happy with and comfortable with this topic. So first, a reminder. How do you find the domain of a function? Well, we start with all real numbers. So we assume as default everything is in the domain. And then we look for two specific areas. The first area of potential problem is we can't have any input that will give us a 0 in the denominator. The second area of input is that we can't have any input that will give us a negative under even indexed radicals. For example, the square root of 3. The index is 2 because it's a square root, and we can't have a negative inside of there because it's undefined. So if there are domain values that give us either a 0 in the denominator or give us a negative under an even indexed radical, we kick those values out, and our domain is what we have left. So let's move on to our first function composition. This one is the addition, or summing two functions. So we normally would do it this way. We have a function f, we've got a function g, and we add them together. So their old names are f and g. But when we add f and g together, we can see that we have, excuse me, if we add x minus 1 and x squared minus 2x plus 1 together, what do we get? We have x squared, we have negative x, and the ones cancel out. So we're left with this, x squared minus x. That's not the same as the original f, and it's not the same as the original g, so we can't call it f or g. So what mathematicians do is they are slightly not creative, and they say it's f plus g. That's going to be the name of our new function, f plus g. So it's just like naming the function Harry or Margaret. Or, for example, if you have your mom and your mom is named Susan and your dad's named Frank, and they have you, and they name you Susan plus Frank, and you're like, that's really embarrassing, but at least everyone knows who your parents are, right? So this f plus g, it's the child function, and at least you know who its parents are. It's f and g. So now you have that notation out of the way. Everything really is the same. We're just adding, subtracting, multiplying, dividing functions. The difference is what we call them, and we'll always call them the sum of the two parent functions or the difference of the two parent functions. The two parent functions will always be in the name of the child function. And of course, parent and child functions, those aren't mathematical terms. I'm just using those to help you understand what's going on. So let's do the difference now. So we are used to, again, writing it this way, f minus g. And if we plug in f here and g there, then we can distribute the negative through. And what do we get? We have x minus 1 minus x squared plus 2x minus 1, negative x squared plus 3x minus 2. So this new function, we call it f minus g of x. Maybe I should write that down, that the new name is, let's write that down. So we read this f minus g of x. That's how this is read. All right, let's move to the next one. Product. The product of f and g, well, you guessed it, we're going to multiply f and g. So we can start with, this is just a multiplication problem of polynomials like we did in previous algebra classes. So let's multiply the first term x through all of the second, and the second term -1 through everything, and see what we get. If we multiply x by x squared, we get x cubed. X by -2x gives us -2x squared. X by 1 gives us just x. -1 now by x squared gives us -x squared. And then -1 by -2x gives us plus 2x. And then we have -1 at the end. And now if we're collecting all of our terms, we've got 1x cubed, we've got -3x squareds, we've got 3 x's, and a -1. Awesome. Sweet. How about difference? So the difference functions, f divided by g, if we take our f again and put it right here, we take our g, we put it down the bottom, and what do we have? Well, we can factor this one in the bottom here. This g in the bottom can be factored. It can be factored as follows. Let's put the numerator up. X minus 1 multiplied by x minus 1. And then we can see that these will cancel, and we're left with 1 over x minus 1. There's our f divided by g of x. A note on domain. So if you have two parent functions, they could potentially have different domains. And how do you deal with the domain of the child function, the resulting function? Well, the way we deal with it is we use intersections. So we take all of the domain that's common of one parent and the other parent. So in other words, what is common between the two parents, that's what we use. So the domain of a function combination, say of f and g, is the intersection of the two domains. So we take everything that both domains share, and that is the domain of the resulting function. So let's try this function, for example. What are the domains of f and the domains of g? Well, we've written them out already. Here's the domain of f, where f is right here, square root of x. We can only take 0 or positive values. The domain of g is anything because it's a polynomial, x squared. So all real numbers for that. So what is common between 0 to infinity and negative infinity to positive infinity? Well, what's common is 0 to positive infinity. Let's write out what actually f divided by g is so we can get a feel for it here. F is square root of x and g is x squared. So we could probably play around with this a little more. Let's keep playing, actually. This is kind of a side note. We may not necessarily need to simplify this more, but let's do it. So we can keep going, and this is x to the 1/2 minus 2, which gives us x to the 1/2 minus 4 halves, which is x to the negative 3 halves, which is the same thing as 1 over x to the 3 halves. And if we rewrote that, we would have this x cubed, the square root of x cubed. So that's what our function is. What's the domain? Well, we just figured out the common domain is here, 0 to positive infinity. But notice we have one issue. We cannot have 0 in the denominator. So in our function, or in our domain here, we've got to take out 0 because there's a bracket here on the left-hand side. So currently 0 is included. So let's take out 0, and I need to give myself a little more room right here. So our domain is, let's just write really quickly. The intersection of the domains is 0 to infinity, where 0 is included. But g of x cannot equal 0. So x equals 0 cannot be included in the domain of f divided by g of x. Let's write that right here. So in other words, the domain d of f divided by g, oh, I don't need that x part, is 0 to infinity. Perfect, perfect, perfect. So let's do one more little exercise right here. What if they asked us to compute f plus g and then said evaluate at x equals -1? Well, let's do it. We know what f is, we know what g is, we can add them together, and that gives us x squared plus 5. So that is f plus g of x. And now if we want to input -1, we have -1 squared plus 5, which gives us 6. That's it. If you guys have any questions, let me know. Thanks for watching.